Okay, welcome back. Chapter 3.4, Dividing Decimals by Whole Numbers. Okay, let's just talk about this in theory first of all. The theory dividing decimals by whole numbers. Say I have a number like 42 divided by 7. Actually, let's say that. That's equal to 6, right? Because 6 times 7 is 42. Now, if I decide to divide a decimal, 4.2, by a whole number, by 7, I could guess that my answer would be 0.6. But I might want to look at that. So if I take my, this stands for 1, 2, 3, 4, okay, 4 point, and then each one of these is 1/10. 1, 2. So this is 4.2. Each one of these is one whole, and each one of these is 1/10. Place value or decimal, cubes, squares, sticks, one whole, 1/10. Now if we wanted to do 100th, it would just be a little dot or just a little tiny guy. Okay, but we're not going to do that. I'm not going to worry about that. So this is 4 2/10, and how do we divide that into 7 pieces? Well, if I were to remember that each one of these wholes is 10, tenths, and I 1, 2, 3, 4, 5, 6, I'm dividing them into 7 groups. There's one group, two groups, there's 3 groups, four groups. Okay, let's just see where we're at. Okay, each one of these is 10 tenths. Whoops, I got to actually be able to write. This is 10 tenths. This is 10 tenths. 10 tenths. 10 tenths, because each one of them is 1, and this is, well, this is 2 tenths, but maybe we should call it 1/10. And 1/10. How many total tenths do we have? Well, we have 42 total tenths. It's equal to 42 tenths. And if I cut those 42 into groups of 7, 1, 2, 3, 4, 5, 6, 7, there's 7 here, and there should be 7 here, and this should also be 7. This should be 7, and this should be 7. So right now, 1, 2, 3, 4, 5 groups of 7, that's 35. But I know I have 42. But if I add one more group of 7, 1, 2, 3, 4, 5, 6, 7, one more group of 7, it should equal a total of 42 tenths. So this is equal to 42 tenths. So each one of these is 42 tenths, or it's 4.2. Okay, 4.2, 4.2, 42 tenths. They're all equal to each other. And I know here I have 4 ones plus 2 tenths. But here I have 1, 2, 3. Let's go ahead and draw it. Write it. 4, 5. I have 6 groups of 7. And so 6 groups of 7. If I had done 7 groups of 6, maybe that would have also done the same thing. We get kind of an answer. You can see how you break up one of these into its little pieces, and it all kind of works out. So that's just theoretical. I'm not going to make you draw these things. I mean, it could be a good exercise, but we're not going to do that. We're going to just jump into what to do with the actual long division, but it's always important for me to show you what's actually happening. Okay, so that's that, and real quickly we'll just do a problem. 7.6 divided by 4. Let's change colors just for fun. 7.6, 7 6/10 divided by 4 wholes, which means that's 4 into 7.6. It's important to always just put the decimal straight up here. It just moves to the top. and to keep everything lined up. You got to keep everything lined up perfectly, okay? Because 4 goes into 7 one time. Okay, 1 times 4 is 4, and 7 take away 4 is 3. Bring down the 6. Okay, and now 4 goes into 36 9 times. It's not really 36, it's really 3.6. 4 goes into 33.6 less than one time, because 3.6 is less than 4. And 0.9 is how many times it goes in. It actually helps us to just think about it as if it were 36. But we're really talking about 3.6. We're keeping everything lined up. 9 times 4, or 9/10 times 4, is 3.6. Okay, or 36. Subtract, we get 0. So this is our answer, 1.9. And if I thought about it, 1.9 times 4 ought to be around 7.6. If I rounded up 1.9, I might do, it's about 2 times 4, which is equal to 8, and 7.6 is just less than 8. So that kind of makes sense. That works. Let's do another problem. This one's a little harder, slightly. 31 and 75/100ths divided by 5. Okay, again, that means it's 5 into, this is divided by, and this is into, and I keep saying it because I keep running into kids that don't know it, and it's really important to understand how this works, how the 31.75 divided by 5 is, how many times does 5 go into 31 and 75/100ths. Remember to put the decimal up on the line. Okay, 5 goes into 31 7 times. 7 times 5 is 30. And we subtract that. It gives us 1. We'll bring down the 7. We have 17. 5 goes into 17 3 times. 3 times 5 is 15. Subtract. That leaves us 2. Bring down the 5. And this one's nice because it goes in evenly. 5 goes into 25 5 times. 5 times 5 is 25. And we can just stop right here because we can see that it goes in evenly. Or we can go ahead and write it out, write down like that. We don't have a remainder. 25 take away 25 is 0. Okay? So 31.75 divided by 5 is equal to 7.35. And we know that 7.35 times 5 should be around 31.75. That doesn't make any sense at all because 7 times 5 is 35. And I see, and you probably already noticed, I made a mistake here. For some reason I thought that 7 times 5 was 30. 6 times 5 is 30, and 6 is the right thing to put in here. Somehow I was thinking ahead and not actually using my head. 6 times 5 is 30. Everything works if I put the right number in. I knew I needed to get to 30. I know that 5 goes into 30. Somehow I put a 7 up there. Will you forgive me? Hopefully I didn't throw you off for the whole problem. 3 times 5 is 30. 31 take away 30 is 1. Everything still works. It's not 7. It's 6, and this is a good reason. This is why we estimate our answers. Now I estimated at the end. It actually doesn't hurt to estimate at the beginning. I know that 5 goes into 31 about 6 times because 30 divided by 5 is 6. Okay? 6 times 5 is 30. 30 divided by 5 is 6. So about 6 times makes sense, and I came up with 6.35. That is, I'm pretty sure is right now. Okay. One more that's slightly harder, and you might wonder if I can actually do a harder one, since I had a hard time with that relatively easy one, but we're going to give it a shot. 4.38 divided by 12. It's harder because this is a 2-digit number. We still have to write it the same way. 2 goes into 4 and 38/100ths. Still want to put the decimal straight up. And I might want to estimate. But in this case, it's a little bit harder. I can't just estimate because I can't figure out how many times 12 goes into 4. But I could just kind of think about it and say, well, how many times does 12 go into 43? And it goes into 30. 12 goes into 36, so we could do 36 divided by 12 equals 3, or we could do 48 divided by 12 equals 4. So it's going to be one of these. Now it can't be 4 because that's too big, so we're going to have to use the 3 and to solve it. So it goes in 0 times here. 12 goes into 4 0 times, 0 whole times. It's going to go in a decimal number of times, 3/10 of a time. All right, and then we just go ahead and multiply. 3 times 2 is 6. 3 times 1 is 3, because 3 times 12 is 36, so that works. And we subtract. Now, I'm going to kind of borrow just to make that work. 6 plus 7 is 13, so 13 take away 6 is 7. So we have 7 left over. Bring down my 8. Does this one work out? 12 times 6 is 72. So 72 divided by 12 is 6. That's pretty close. Let's use 6. 6 times 2 is 12. 6 times 1 is 6 plus 1 is 7. So 72. 8 take away 2 is 6. So we're left with 6. This is typically a remainder, but it's not a whole number remainder. 6 is bigger than, our whole number here is 0. This is actually a decimal remainder. And what happens when we start using decimals, and some of you will remember this because we've done this before, we did this last year, that when you get to the end of a long division problem, if you don't want to have a remainder, and with decimals you really can't, it's not a realistic remainder, because this 6 really stands for 6/100ths. We can't put a remainder of 6/100ths. Well, we could, but we're going to just go ahead and add a 0 and bring it down and call it 60. Okay. Cool thing is that's going to work because 12 goes into 60 an even number of times. 5 times 12 is 60, and then we don't have a remainder. We're done. Okay, so we had to add a 0 or a placeholder so that we could continue to divide. We had 0 thousandths, but we went ahead and we wanted to add that 0 on so that we could, say we had 60 thousandths, so 12 would go into that 5 times. So 4.38 divided by 12 is 0 and 365 thousandths. That's the answer. Okay, that's all. You don't have to listen to any more. We're done. I'm going to go ahead and draw something on the back, and on the next slide here, we're going to blank it out and go for it. I had a couple of ideas, and none of them make a lot of sense. It's just kind of what I was feeling right now. I was feeling like there's a nice shady tree, and kind of the roots are hanging off, kind of hanging off the edge of the bank. Maybe there's a little river going down below, and the tree is just hanging out there. There's maybe a limb here, and a limb going off this way, and some branches breaking off of the limbs. It's always nice to have branches. And I don't know, that's starting to look a little confusing, but we got this going on anyway, and it's kind of nice to have a little tree. And maybe we can add some foliage to our tree. I don't know if there's anything in here that'll do it. What do we have? I don't know what that does. It doesn't seem to do anything. What does this do? Ooh, that's kind of a cool one. I like that. We can kind of make it kind of look interesting. We could probably even go back to what we were doing and put a a little more branches coming out here and there. That's the wrong color, but it'll work. We could add some, texture to our tree with this color. Maybe some other texture. Make it look kind of fun. Put a little knot hole right here where it got cut off. And then we could get out this spray, do some coloration. I don't know what you guys think. I'm kind of doing it quickly. I think if I took a little time, I'd do a better job. But we're not going to take a little more time. We're going to just call that handsome right there. And add some foliage. You won't be able to see the top of the tree. It's up outside your screen. Alright, and some of the branches are kind of covered up by the greens. Just more of an idea of a tree. It kind of feels like leaves. Alright, yeah, that works. And then on the ground down here, you got kind of the grounds going on, and maybe there's some little bushes growing here. Oh yeah, that looks good. And we'll call these like little flowers. Yeah, that's right. Now maybe put some cute little flowers on the ends of them. There we go. And maybe if we actually sort of make woo, that's not so good. I forgot to give you the real-life application. I had a real-life application I was going to give you, and that would have been really good. Can I do this? Can I stretch that out a little bit? Well, what I was hoping to do is color everything in here green, but I think you guys have seen what happens when I do that. It might not work if I try to fill it up with a nice dark green color. Yeah, see, it did the whole thing. That's not going to work. So I think I'd have to use something like this and come across and see, but I always end up catching that, so I'd have to go this way. Make a solid line, then fill it with green. Find a better green. It still didn't work. Oh, well, that's too bad. It would have been a lot nicer if there was a faster way to do this. Ah, there's a faster way. That's cool. I'm just kind of just learning here, just like you guys. Although now my greens don't match. Okay. Well, I was thinking about this little turtle guy. Little turtle guy, and he's got his little shell. He's kind of a purple turtle. And he's got some feet here. Yeah, he's a happy turtle. He's on a race. He's planning to win. He's stretching out. He's a purple and green ninja turtle. And he's on his way to win. Wow, that was strange. I was going to bring you guys some clothespins, but I looked around in my cupboard and I didn't have very many. So, okay, that's the masked turtle. Here's his mask. And he's a ninja turtle with green spots. Okay. The only other thing I could possibly do is try to fill in the sky. There you go. And I thought of one other thing. We could give you some nice white marker felt tip is invisible. Oh, well, we want this one. Well, we don't care if it's invisible. We're coloring over the blue. How about this? That's gray. Oh, they're telling me I need to use an eraser if I want to do clouds. I should use an eraser. Oh, but I can't. There's my cloud. And just for fun, we'll put a couple little birds in the sky. There we go. Okay. Have a nice night. Did I actually convince you to watch the whole thing? I might have. Well, I didn't know what I was going to draw when I started, so I guess, I fooled both of us. All right, have a good night.